This is Chem 101. We're going to be introducing Chapter 1, Chemistry and Measurements. In this chapter, we will discuss about scientific method, definition of chemistry, units of measurement, scientific notation. We will do significant figures, conversion factors, and the last part will be density and specific gravity. So science is a knowledge that is gained through evidence. How do we acquire the evidence? By seeing. In order for us to gain evidence, we need to do observation. And the other thing that we need to do is measurements. Every time we do a measurement, this is a numerical observation. When we do science, we apply what is called the scientific method. In the scientific methods, the first thing we have is a hypothesis. This is a proposed explanation of a phenomena. What do we do with this hypothesis? Well, we test this as many times as possible and try every possible way to prove the hypothesis wrong. If this hypothesis is constantly proven right, then we have arrived to what is called a theory. A theory is an explanation that fits all available evidence. Of course, the part of science that we're studying in this class is chemistry. What is chemistry? It's the study of matter and the changes of matter. What is matter? Well, matter is stuff. Anything that has mass and occupies space. Matter is composed of very tiny particles, and these are called atoms. In science, we use what is called units of measurement. We either use the metric or the international system. Why do we do this? Because in science, like in life, people speak different languages. Well, in science, people could use different units of measurements. So all the scientists have agreed to use the international system as the units to report the results. So for length, we have meter. For volume, liter. For mass, grams. And for temperature, we use Celsius if we use the metric system, or Kelvin if we use the international system. For times, we use second, and here are instruments that are used for this. For example, we use the ruler for the length, graduate cylinder for volume, balance for the mass, thermometer for temperature, and a stopwatch for second. This table over here represents some common equalities. For example, here we have the U.S. System. Here we have the metric system or the international system, and in here we have what is called the metric to U.S. system. In the U.S. we use feet, for example, and that's 12 inch, 1 yard, 3 feet, 1 quart is 2 pints. In the metric system, we say 1 kilometer is 1,000 meters, 1 centimeter is 10 millimeter, and like that. Please be aware that all these US conversions are going to be provided for you, and any of these also will be provided to you too. You don't have to worry about memorizing any of these, neither this nor this. Some of the metric will be provided, some of the metric will not. For that, you need to check the Blackboard. There is a sheet there that tells you exam sheet. In that sheet, you will be able to see what is going to be provided and what is not. Whatever is provided, you don't need to memorize. Whatever is not provided, but you see that we are using it, you need to memorize. In science, we use what is called the scientific notation. Chemistry involve a very large number. For example, the number of atoms in 12 grams of carbons. Look at this number. It's very, very large. If we look at the diameter of carbon in meters, look at this. It's very, very tiny. So what we do, we use what is called scientific notation because it's a more convenient way than writing all these zeros. When we use scientific notation, we use what is called a coefficient. This coefficient is a number between 1 and 9.9999. The other thing is a power of 10 and then the unit. For numbers that are very, very large, the power of 10 is going to be positive. For numbers that are very, very small, the power of 10 is going to be negative. So how do we do scientific notation? Well, the way we do it is we write a number. For example, this one that we see over here. We assume the decimal place is here. Then we're going to take it all the way to our coefficient. The coefficient had to be a number between 1 and 9.99999. So our coefficient has to be 5.2 times 10. Because this is a large number, we know that the exponent of our 10 is going to be positive. So we're going to go from 1, 2, 3, and 4. So the exponent of our 10 is going to be 4. This one over here is a very small number, so we know that the exponent of our 10 is going to be negative. We have the decimal place here, and we're going to move it all the way to here. Why here? Because our coefficient has to be 3.78. Please notice that our coefficient cannot be 37.8 because this number is not between 1 and 9.99. So in order to go from here, we go 1, 2, and 3. So our exponent is going to be negative 3. So let's do this problem together. Write the following in scientific notation. So we look here, our coefficient has to be 5.43. Because it's a small number, our exponent is going to be negative. It's going to be negative. And what we do is we go 1, 2, 3, and 4. So it's going to be negative 4. And don't forget to write our units. This number over here is a very large number. So we know that the exponent is going to be positive. So we're going to grab 1.024 times 10. And we know that that exponent is going to be positive. So we go from here. 1, 2, 3, 4, 5. And this was meters, sorry. This one is a very small number. We're going to take our decimal point to that place. It's going to be 5.65 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Negative 7 seconds. Alright, so now let's do the opposite. We give you numbers in scientific notation, and then you're going to have to write them in standard numbers. So we know that this is going to be 2.3, and all the zeros are going to go here because since the exponent is negative, we just write a bunch of zeros, and we're going to take the decimal place from here, move to the left 4 times. 1, 2, 3, and 4. So our decimal place is going to go right here, and what we do, we delete the extra zeros that we wrote. We do the same with this one, 6, 4, and we write a bunch of zeros. Why? Because we're going to move 3 spaces to the right. We're right here. 1, 2, and 3. We stop right here, and then we delete the extra zeros.